Good evening all, and welcome to tonight's talk as part of the Young Scholars Institute in London. The Young Scholar Seminar Series was established in 2017 with the aim of creating a platform giving postgraduate students the opportunity to present their research to the wider public, to encourage the exchange of knowledge and facilitate networking opportunities. I would like to use this opportunity to invite young academics researching into global or Turkey-related matters to present their findings and become part of the Institute's growing academic network. As for tonight, we will be delving into the topic of big data with Abdullah Cemil Akçam, who will be sharing with us his research into forecasting Turkey's 2017 presidential referendum using big data. Abdullah graduated from computer engineering at Middle Eastern Technical University in Turkey. Following graduation, he started working at Ericsson as a service engineer and moved on to Turkish telecoms regulator. In the meantime, he completed his MBA at Bilkent University, and in 2017, he was awarded the Chevening Scholarship to complete his Masters in Business Analytics at Queen Mary University of London. Currently, he is a PhD candidate at Middle Eastern Technical University. Before passing on to Abdullah, I would briefly want to touch on the topic for those who may have little background knowledge. So on the 16th April 2017, Turkey voted for constitutional amendments transforming the country from a parliamentary democracy into a presidential system. In this historic referendum, the country was to vote evet, yes, or hayır, no. Results was in favor of yes voters, and the presidential system was adopted in Turkey. Were the results predictable? Is it possible to take voters' sentiment with high accuracy using big data? Abdullah will be talking about how data derived from social media platform Twitter may show voting intentions in a situation like the 2017 referendum in Turkey. Please also note that there will be a Q&A section at the end of the talk, so if you do have any question, please share it with us down below. I will now like to pass it on to Abdullah Cemil Akçam. Welcome, Abdullah.
Thank you very much, Ayşegül. Good evening. Shall I start now?
You can start now.
Okay, let me share my screen first. Yes. You can see, right?
Yes.
First of all, this is the holy month. As Ayşegül mentioned, today I'm going to talk about Turkey's 2017 presidential referendum. Back in 2017, we had done some analysis using big data tools to forecast the referendum result. So this is my outline of the presentation. First of all, I'm going to give you some context about the referendum and what happened in Turkey in 2017. And then I'm going to give you some information about data we have used for the analysis. And then I'm going to talk about why we have utilized big data, why big data is suitable for our project. And then I'm going to talk about the method we have used for the analysis, and then results of the method. And then I'm going to give you some insights about the how our model is working. I'm going to show it in action. And then I'm going to talk about the actual referendum results. And at the end of the presentation, I'm going to answer the questions you may ask.
Just before starting, do you want to put into slideshow mode by just clicking the icon above? All the way on top, orange area.
Let me check. Can you see it now?
Yeah, I can see, but if you can just put it into slideshow mode.
Okay, yeah. Now?
Yeah, perfect. Thank you.
Now, this is the introduction. Here I want to give some context. As Ayşegül mentioned, in 2017, 16th of April, we have held a referendum in Turkey for some constitutional changes. The biggest change in the referendum was as Ayşegül mentioned, the style of the governance in Turkey. And the voters were asked if we should change to a presidential system instead of the parliamentary democracy. And there were only two options in the referendum, yes or no. And in that sense, it was a simple choice. Only two choices. There were no many political parties, or there were no too many choices. Only yes or no. But it had resulted in some kind of polarized environment in Turkey. So on one side there was the so-called yes camp, and on the other side there was the no camp. And because of this, the voters were polarized. And there were some polls for predicting the referendum results. But these polls were kind of conflicting with each other. Some of them showed that yes votes were higher. On the other hand, some of them showed that no votes were way higher than yes. And because of this, people were not able to predict the actual outcome. Another thing, in that time, people were using Twitter as a medium of communication very frequently. People were discussing and debating the topics related to referendum. And Twitter was also used by the political parties for campaigning, both the political parties supporting yes and also no. Because of this, Twitter was some kind of battleground for the political parties and also a medium of communication for the voters. So at this point, the question came up: can we forecast the referendum results using the tweets? This was an interesting question for us because people were tweeting, but if does it have any actual value for our analysis? So what kind of data we have used for the analysis? First of all, our data universe is all tweets in Turkish language. The language is determined by Twitter itself. Twitter has some kind of filters, and when you ask them to send Turkish tweets, they do that. And in that time, there were 8 million tweets per day on average. But as we get closer to the referendum, this number increased 10 million per day. And this is a high number. So this is the data. Now I want to talk a bit about why big data. Big data is a recent technology, and all the companies, all the institutions, all the organizations are talking about big data, and they claim that they are using big data. They are highly technical and they can use big data. But back in 2017, it was kind of buzzword. Because some people were doing some traditional analysis and they were claiming that they are doing big data. So this is a tweet. This is a characteristic tweet from that time. As you see, it is related to referendum. It has 2 hashtags, one of the 2 most popular hashtags. It has some text. We can see the user profile, user picture. We can also see the time and the location. This is and also the user device. This is a perfect tweet. We have all the information for analysis. But behind the scenes, things are not that creative. This is the same tweet in raw format. As you see, when we get behind the scenes, everything gets a bit complex. So this is so-called a JSON format. The same tweet, too many information, and when you try to dig into it, you may be lost. So there are some viewers for this. It shows the same raw data in a tree format. As you can see, we have some tags here, text, and this is the actual text. This is the tweet text. And also,
I think you need to stop sharing the PowerPoint because we can't see the screen at the moment. You can just see this PowerPoint. Not the link.
Sorry.
Yes.
Now you can see, right? Sorry for that. This is the same tweet in raw format. As you can see, it is a bit complicated. When you look at this, it is ugly, it is complex. There are too many details, too many different, you can see here, different characters. And this is the nature of our job. We deal with complexity all the time. But there are some viewers to see the same text file in a more readable format. This is called a JSON format. And as you can see here, we have some tags and we have the actual data. So this is the text of the tweet, and this is the actual tweet text. And also we have some other fields. For example, we have some entities, and under the entities, we have some hashtags. So as you can see here in this tweet, we have these two hashtags. So I don't want to give too many details about this, but I just wanted to show you that behind the scenes, everything is a bit complex. It is not that easy to see some pretty tweets, some pretty emojis, and pretty text on the Twitter website. So now let me move to my slides. Okay. So why big data? As I said before, big data might be some kind of trick or buzzword, or it might be a suitable choice for the project. So there is the so-called 3 V's of big data: volume, velocity, and variety. Before starting a project, you can determine if you should use big data, asking 3 questions. Is my project suitable for big data in terms of volume, velocity, and variety? Let's start with volume. So as I said before, we had 10 million tweets per day, and each tweet is almost 5 kilobytes. When we multiply, it makes 50 gigabytes per day. So this is a big number. And we can check volume, 50 gigabytes. So when you calculate, for example, when you get the data for 1 month, it makes some kind of terabytes. So velocity is the speed of the data flow. So when you divide 10 million by the number of seconds in a day, we got more than 100 tweets per second. So this is not uniformly distributed throughout the day. There are some peak times for tweets, and there are some low times. So for example, evenings are peak times for the tweets. So in the peak times, this is more than 100 tweets per second, and this is also a high number. And the last one is variety. Variety describes how variable, how fast is your data is changing. So as I showed you before, we had the JSON format. We have too many tags, and it changes frequently. Sometimes they add some new fields, sometimes they remove it, and you should be able to adapt to this fast change very quickly. So as we can tick all of the V's, all the V's, big data is a suitable choice, suitable technology for our analysis. So okay, how did we use big data? Here, this is the most technical slide in my presentation. I try to keep things simple. I try to explain the technical details in a more simpler format. But if you want to dig into details, if you want to learn more about some technical aspects, please ask the question, and I'm gonna answer. So first of all, Twitter has data. Twitter has all the tweets, and then you make an agreement with Twitter, and you ask for data. And if you can make the agreement, they send you the data using real-time API. They have 2 APIs. One of them is called REST API. The other one is called real-time API. The difference is, in real-time API, you get the tweet as soon as it is posted. So if someone posts the tweet now, I can get the same tweet in less than a second in my system. So in doing so, we have used Apache's Flume tool to fetch the data in real time, and then we have stored the data in HDFS. HDFS is short for Hadoop Distributed File System, and it is called Hadoop by most of the people, and it is one of the most popular big data tools in the technology world. So after storing the tweets in Hadoop HDFS, in order to query the data, we have used Hive and some other querying technologies such as Impala and Spark, but mainly Hive is the main query tool for us. Here I want to give an anecdote. When preparing for this presentation, I have looked at our old source codes for fetching the tweets, and I just wondered and run the source code. And because of that, my Twitter account was suspended for 3 days. I hope they unsuspend quickly, but right now my account is suspended, unfortunately. So after downloading, after fetching all the Turkish tweets, we needed to subset the referendum context. So we cannot use all the tweets for the referendum analysis, because people talk about all the different topics on Twitter. Sometimes they talk about some recent topic. Sometimes they talk about a song, some sports game, or sometimes they talk about some cartoons and etc. So we needed to determine the tweets related to referendum, and in doing so, we have utilized the hashtags. This is the easiest method, and this is the most convenient method. So on the left-hand side, you can see that we have some hashtags leaning yes. It means that if people use these hashtags in their tweets, mostly they are supporting yes. So in the middle, there are some hashtags leaning no. And on the right-hand side, we have some hashtags related to referendum, but it is neutral, neither yes nor no. So, okay, this is the last step in data preparation. After subsetting the data using these hashtags, our data is ready for the analysis, and we can move on to the actual analysis. So what is the actual analysis? How can we analyze the tweets? There are some methods, but the most popular ones are sentiment analysis and natural language processing. Natural language processing is a bit complex method, and since we didn't have enough time for this project, we have used sentiment analysis. So what is sentiment analysis? It is basically extracting the sentiment, the idea, the opinion from a text. So we take a text, we use some methods to analyze it, and then we say that, okay, this text is positive, this text is negative, or this text is angry, or this text supports this opinion, and etc. This is also called opinion analysis. So basically, it has 4 steps. Actually, there are some very deep mathematical details, but I don't want to dig into them here. First of all, we have prepared a sentiment library. Sentiment library is kind of a dictionary, and in this dictionary, we have many Turkish adjectives. For example, iyi, kötü, güzel, büyük, küçük, and etc. And by the way, this is done by humans. So for each word, we have some kind of sentiment score. So for example, for iyi is a positive adjective, and we have a sentiment score between -1 and +1 for that adjective. Here, since this is done by humans, it is prone to errors. So for example, I may assign -0.7 for kötü, but some other person may assign maybe 0.8. It may differ, but to avoid this trap, we have averaged out all the scores, and then we got the sentiment score for each adjective in Turkish. After that, in the second step, we break each tweet into its components. It is called parts of speech, and it is called posts for short. And then identify the sentiment-bearing phrases from each sentence. So, for example, I can write a long text, but only some parts of the text may bear some opinion or sentiment. And at the end, in the last step, we assign a sentiment score for the parts of speech and also the whole tweet. So, in order to clarify, let me show you an example. Here we have two comments about a baseball game for the same game, two different comments. The first one goes like this: terrible pitching and awful hitting led to another crushing loss. So obviously, this is a negative comment. I can understand this as a human. The second comment is bad pitching and mediocre hitting cost us another close game. So it is also a negative one, but compared to the first one, this is less negative. So how can we do the same analysis using computers, using machines? As you see, the first sentence is the first sentence was broken into its components like this one, and these are the sentiment bearing phrases from the first sentence: terrible pitching, awful hitting, and crushing loss. So we have sentiment score for each of the sentiment bearing phrases, and then at the end, on the right hand side, you can see we have the total sentiment score for the whole comment, 0.4 minus 2.4. Sorry. The second one has a smaller number. It is minus 0.9. So, for example, let's compare the first sentiment bearing phrase: terrible pitching and bad pitching. Obviously, terrible is it is a stronger adjective to describe the same thing. So it has a less, in absolute terms, it has a higher sentiment score. So this is the basic idea behind the sentiment analysis. So this doesn't show all the complexities, but the basic idea behind the algorithm is this: assigning some sentiment scores and then obtaining the sentiment score for the whole tweet. So this was not that easy. This was not that smooth, let's call it, because we had some challenges with the data. First of all, some people post tweets with hashtag only. They only post hashtags, no text, no other thing, no opinion. So if there is no text, we cannot do any sentiment analysis because we don't use hashtags for the analysis. So we had to exclude all those tweets with hashtags only. Another common data challenge is there are some tweets with picture only. They just post a picture, no text, no comment. Sometimes there might be some text on the picture, but in order to extract that text, we need to do some image processing, and image processing is a advanced analysis. So we didn't have time and resources to do that. So we had to exclude all those tweets. And the last one is use of emojis. You know, emojis are widely used when texting and posting tweets. It can be good or bad. It can be good because a smile emoji certainly shows a positive sentiment. But it might be misleading sometimes because, as we see in the referendum context, some people support no, but at the end of their tweets, they put two smiles, okay? Two smiles, but it is negative. So because of this, we had to exclude all those tweets with emojis. But we were lucky because, as I said before, we had millions of tweets, millions and millions of tweets for the analysis. And even if we exclude all those tweets I showed here, we had plenty of remaining tweets for the analysis, so it was not a big loss. So this is the most interesting part, maybe. After we are satisfied with our model, we made some tests to see if to calculate the accuracy rate of the model. So how can we calculate the accuracy rate? It is simple. We compare the model response with human evaluation. So we have a set of prediction data. This prediction data are the tweets, and some humans give some sentiment scores to those tweets. For example, humans look at the tweets and they say, okay, this is yes, this is no. And then the same data were predicted by the model, And then we compare, and 94.6% of the responses are the same. So we can say that our accuracy rate, our success rate with this model is 94.6%. So this is a high percent. I think this is a big success for a model. So at this point, we felt satisfied that this model is good enough to make some forecasts for the referendum results. There's a big question here, if there's any data overfitting. There were no chance of data overfitting because we have divided our data into two, training data and prediction data, and we didn't use the training data for prediction. And so because of that, I can say that we have 100% avoided the data overfitting problem. So this is our model forecasting the referendum results for 10 weeks. As we go on the right, we get closer to the referendum. As you can see, there is no big difference between yes and no votes as we get closer to the referendum. Most of the time, always, not most of the time, always, votes for no are higher than yes. And the difference is, at the very beginning, it is 10%. And it fluctuates as we get closer to the referendum. And at the very end, one day prior to the referendum, 53% no, and 47% yes. But we cannot just say that, okay, these are the results and this should show the actual referendum results. No, because the results from Twitter analysis should be taken with a grain of salt. Why? First of all, and first and foremost, the most important point is Twitter social media environment may not reflect the general audience in Turkey. It may not reflect the general voting intention in Turkey. Why? Because not everybody is using Twitter. Not everybody is posting tweets. Not everybody is talking about referendum. Okay, some people don't want to express their opinion loudly. Okay, they just want to go and vote. So we saw that most of the users on Twitter platform were leaning towards higher. I mean the no votes. So if Twitter was a country, in that country, no was prevailing mostly. But the referendum was held in Turkey, so we should look at Turkey population. And as a rule of thumb, we have added 5% to evet, yes votes for the analysis. So if in this graph, if for the last week, for the 10th week, if yes votes are 47%, we add 5% to it, and then it makes 52%. And then we say, okay, yes votes might be slightly higher than no votes. So in order to be 100% sure about these results, we need to have some kind of Twitter demographics. Who are the Twitter users? Who are posting tweets? Where they live? What kind of social and economic status they have? What is their age? What is their gender? What is their educational level? So if possible, what were their previous political choices and political tweets? But this is not a realistic expectation in real life, because who would tell you their previous political choices, previous votes, and what political party they support, and so on. So this is not a realistic thing. So because of this, we cannot be 100% sure about the results from the Twitter. So what can we do about this? We may augment the results by other social media. For example, we may have a Facebook analysis. We may have Instagram analysis, and then using all of them, we may draw a conclusion about the referendum results. And I said in the previous slides, polls were misleading, conflicting, but polls are polls, okay? We need to use them. And polls are the most widely used and the most traditional methods for predicting elections and referendum and all kinds of voting things. So we have to use them. We have to use them all the time, but we have to use them as an augmentation to the analysis from the social media. So what happened at the end? This is a headline from Financial Times. This is the actual results. Evet won, yes won. As you see, the difference between yes and no was less than 2.5%. It is very close. It is a very close race. And when you see the number of votes and when you see the difference, it is very small. It is very it is a chunk. It is a very small chunk. So there is a concept in analytics, data analytics, margin of error. When you make a prediction, when you make a forecast, you cannot predict anything with 100% accuracy. There should be some kind of error term, some margin of error. And most of the time, it is accepted as 2%, 3%, and sometimes, if context allows, it is maybe 5%. So in our context, we need to have some fat error margin, and this is within the error margin of our model. So our prediction was 52%. So it might be 52% plus 2.5% minus 2.5%, and it is the difference between yes and no. So this is very interesting, and this shows how difficult it is to forecast this kind of close games. If there was big difference between yes and no, it might be a bit easier to make some forecast, make some analysis. But in this kind of narrow differences, it is very hard to make highly accurate forecasts. So that's all from me today. Thank you very much for listening to me. If you have any questions, I am more than welcome to answer. And I have my email and Twitter handle here. As I said before, my account is suspended, Twitter account. Right now, if you search for my name, you may have a blank page and saying suspended. But in a couple of days, I hope it will be opened again. Thank you very much. Ayşegül?
Thank you very much, Abdullah. Amazing to see the level of accuracy that was achieved through the model. And big data is something that I'm particularly a stranger to, so it's been great having an insight into the background information. So thank you for that. If anyone has any questions, we can take them now. You can drop it through the question and answer box below. I'll read it out for you. So, do you think this model could be used to analyze social change alongside predicting referendum outcomes? So, analyzing social change.
Yes, but it is difficult. The short answer is yes, but the disclaimer is it is difficult. Why? As I showed before, what did we forecast in our model? What will happen at the end of the referendum? So there were only two choices, yes and no. Okay. So if you flip a coin, there is 50% chance that you'll have the correct answer. Okay. So when we compare the results with this one, our prediction, our model for the referendum might seem simple. But okay, let's see social change. We can do this. We can analyze the tweets over time, or maybe Facebook posts, maybe Instagram posts. We may analyze it over time, and we may also analyze the user demographics over time because it may change. And then we may draw some conclusion, but we should be careful. We should support our analysis with some theories, in the social science. We cannot say that, okay, I saw this trend on social media and this is a real thing. We cannot say that, okay? We should have some kind of background science and sometimes hard science to support our analysis using social media. This model cannot be used directly, but the same methods, sentiment analysis, maybe natural language processing, the same mathematics can be used to analyze this social change.
Perfect. Thank you very much. Is there any more questions? Okay, here we go. So one of our viewers is asking, have you considered using other social media platform data to reach more credible results?
Yes, very good question. Actually, we tried analyzing Facebook, but Twitter is kind of easier because, you know, on Twitter, people just post some tweets. It is just a text, and it has some character limit. You cannot post very long text. But Facebook and Instagram are a bit different. For example, on Instagram, people share pictures and videos and some kind of effects, some picture effects, some Photoshop effects, you know, some, and recently they post some reels and tweets and etc. Okay. This kind of data, video, and this is in general, it is called multimedia. Multimedia is very hard to analyze. So what kind of information we can get from a video? Lots of information. But as a human, when I watch a video, I can infer many information from that video. But as a machine, it is very hard to do that. We tried to use Facebook. We couldn't do that. Why? Because Facebook is a sticker in their data handling policies. They don't allow you to download many Facebook posts. After some limit, they ban you as they suspend my Twitter account. Because of that, we couldn't do that. But it should be attempted, I should say. It should be attempted because people share very valuable information on social media, and we should find ways to somehow analyze those data, to draw some conclusions, to make some analysis about any topic of interest we may have.
Yeah, perfect. I have
Another question.
I have a question. I want to ask.
Ayşegül, there is another question on chatbot.
1 second.
How do you get permission to use data from data providers? Do you pay for them? Yes, this is a tricky question. Actually, you may be surprised, but yes, we pay for the data, and you may be surprised that these social media platforms are selling the data. Okay, they are selling tweets. This is most people think that they don't do that, but they do that. They sell the data, and you make an agreement based on number of tweets you are going to fetch. And the logic behind this is they don't allow to download the private tweets. You know, there are some protected accounts on Twitter, and you cannot see the tweets if you are not a friend of them. But for public tweets, they sell it. And the logic behind is they say that, okay, you post this publicly, so I can sell it. But the price changes according to platform. So it is not the same as buying a tweet from Twitter than buying some post from Instagram. It is different price.
Okay, perfect. Thank you for that. Would you say this was a difficult project? What was the difficulties you faced?
Well, it is a difficult project. It was a really difficult project because, you know, in most of the projects, you have a sponsor, okay? You have a sponsor for the project, and the sponsor is paying the money. And since they pay the money, they expect concrete results. So when they sponsor this social media analysis project, they expect that you should tell me the results of the referendum before the referendum, okay? Their expectation is this. But it is not easy to deliver this kind of expectation, okay? As I mentioned before, first of all, the nature of forecasting requires some kind of uncertainty, some kind of error, some kind of prediction error, okay? We cannot be 100% sure about anything when making predictions. So it was very difficult in this sense. And it was also difficult for the technicalities. For example, big data, the architecture, the Hadoop distributed file system, and also fetching the tweets in real time. These are really highly technical problems, and we needed to have some kind of algorithms, software, a combination of algorithms, software, and hardware. These are all time-consuming and expensive investments, infrastructure investments. We had also paid for the tweets, you know, it was also a difficulty. And also the big data itself, it was another difficulty. So I can say that this was a difficult project overall.
Yeah, thank you for that. We have one question here. Are you planning to publish details of your method in an article?
Well, actually, we have prepared not an article, not an academic article, but we have prepared a very, very detailed report for the sponsor. But it is not public. It is for their private use. And they don't allow to share the report with public because they don't want to be seen as analyzing people's tweets and monitoring people, monitoring social media to determine some kind of trends. Because of that, they don't allow. But maybe we may have another project, and we may use the similar methods and similar source codes, and we may publish an article, and we may publish all the details about the methods and data and etc. in that article. But for this project, we cannot do that. Sorry.
Right. So they should keep an eye on your other projects and maybe follow you on Twitter for that.
Yes, if they can, after unsuspended.
Okay, we have one more. What do these kinds of models suggest about the future of data privacy? It's kind of linking in with the previous question.
Well, actually, when you enter into this data analytics world, you see that there is no such thing as privacy, because sometimes you see, for example, when I was looking at the tweets, the people's tweets, I was kind of thinking it should be private. Come on, this man posted this tweet on Twitter, but if he knows that I am looking at his tweet 5 years ago, he should be kind of concerned. Okay, it might be a ridiculous tweet, it might be some kind of joke, it might be some serious opinion, but maybe that opinion has changed over time. So what I see is there is no such thing as data privacy. So my personal recommendation, if you are using social media, do not share your private data anytime, anywhere, in any platform, even if the platform owner claims that they are using very big technologies to protect your personal data. Don't believe in them. Post something that you may forgo. Okay, keep in mind that someone may be downloading your data for analysis.
Yeah. Perfect. Okay, we have 2 last questions. I think we'll ask these as well and then finish it off. Okay. So where else is big data used to such success? Should I repeat it?
No, I'm just looking at the actually big data nowadays, big data is it is a prominent technology. It is used in a wide range of domains. For example, it is used in telecommunications. It is used in drug discovery. It is used in text analysis. It is used in marketing. For example, brands and companies keep an eye on their customers and potential customers using big data, because the amount of data in recent years doubled, tripled, and quadrupled. You know, it is data expansion is huge. It is exponential. It is called data explosion. Every year we are adding volumes and volumes of data. So the traditional techniques, traditional relational databases, traditional statistical methods to analyze those data, they are not working no more anymore. So big data is currently it's a new technology, but in the near future, maybe in 3 years, maybe in 5 years, it will be the default technology for analysis. And nowadays it is combined with cloud computing, and you can put your data on the cloud, and you can use the big data tools on the cloud. So it is not as expensive as it is in the past compared to the past. And now it gets cheaper because technology companies make big investments on big data and cloud computing. So the short answer is big data is used in everywhere. And some final note, for example, in London, TfL is using big data to optimize the underground scheduling.
Interesting. Thank you. And just to close it off now, our last question. If you could go back to redo this project, what would you change?
Yes, first of all, I would change some of my team members. But in that time, I didn't have power on selecting the project members. So we had to make a team out of those people. But the jokes aside, maybe I would hire a data scientist to help us. Because in that time, I have some knowledge about data science, but I am not an expert. I am not a domain expert. Maybe someone with big experience in social media analysis, some kind of niche expertise. That kind of person would have helped us very much, because it was a learning process for us. We have read many articles, we have read many white papers about big data, about social media analysis, and at the end of the day, we couldn't be sure if we did a correct job. So our model accuracy rate was high, but maybe it might be higher, or maybe we might have extract some more interesting how can I say, some interesting insights from the same data, because theater data is very rich. Maybe it might tell us something different if we can analyze it more successfully.
Yes, thank you very much. Abdullah, thank you for your time, and thank you for sharing your evening with us.
You are welcome.
It has been a great presentation, and I'm sure a lot of our attendees have learned something new.
Thank you.
Thank you very much. And you shared with your email with everyone. So if there is any further questions, you could always ask Abdullah on his
Sure. Yes, sure.
account when it's back and running. But for now, thank you very much. We look forward to seeing you in our future events. We have some more interesting talks coming up very soon, and it will be announced on our social media accounts at YEE Londra. So if you can give us a follow on that, you can keep up to date with any of the upcoming events. Thank you very much, and keep well and safe. Take care.